I'm going to go over how to do these half-life problems. The first one, radon has a half-life of 3.8 days, and after 7.6 days, 6.5 grams remain. What was the mass of the original sample? So we can figure it out like this. At 0 days, we start, and the first half-life is 3.8 days, and then we add another 3.8 for the second half-life, and it goes to 7.6 days. So these are our days, our half-life. And it halves 2 times, so it jumps here and here. So this is 2 half-lives. So we count it as we go between them. We do not count it as 1, 2, 3, but we count it as the jump between them. And so we have 2 jumps between, and so we have 2 half-lives. And so we can figure this out by knowing that we have had 2 half-lives, and at the end of 2 half-lives we have 6.5 grams. So that was at 7.6 days, but what about at 3.8 days? Well, it would be double at 13 grams. And then what about at 0 days? We're going to double it again to 26. So remember, every half-life it halves. So it goes from 26 to 13, then to 6.5, and that was our ending. So we can kind of work backwards. And so our answer to number 1 is 26 grams. Number 2, the half-life of cesium-137 is 30.2 years. If the initial mass of the sample is 1 kilogram, how much will remain after 151 years? So I'm going to do this problem over here. And it says that at 0 years, we start off with 1 kilogram. So I'm going to put here 1 kilogram at 0 years. And it says that my half-life is 30.2 years. So in 30.2 years, I'm going to have it. So it's going to go to 0.5 kilograms. And then in another 30.2 years, so I'm just going to add 30.2 to this, and I'm going to get 60.4. Okay? And then at 60.4, I'm going to go half, so it's going to be 0.25 kilograms. And then I'm going to add another 30.2. Notice that the years don't like double or whatever, because the half-life is going to remain the same amount of time. So another 30.2 years, and I'm going to get 90.6 years, and it's going to half again. And so half of 2.5 is 0.125 kilograms in 90.6 years. And then I need to add 30.2 again, and I'm going to get 120.8 years. And I need to halve this again. And so if you are if you can't do this in your head, just kind of do it off to the side. So you need to halve it. So divide 0.125 by 2. And you're going to get 0.6. I'm going to subtract. And I'm going to bring this and add a 0 and bring it down like that. So there's my long division. And so at 120.8 years, my kilograms have gone to 0.0625 in 120.8 years. And then I'm going to add again plus another 30.2, and this time I'm going to end up with 151.0 years, which is what the problem says after 151 years. And so now I need to take 0.0625 and I need to divide it by 2. I got to half it. And when I half it, and again, if I need to, off to the side, you can just go ahead and do a long division problem. Like this. 0.03125 kilograms. And so that's the answer to number 2. So bringing my paper back here. All right, so now we're at number 3. Carbon-14 has a half-life of 5730 years. Consider a sample of fossilized wood when alive would have contained 24 grams of C14. It now contains 1.5 grams. How old is the sample? So I'm going to bring my paper back this way to give myself some room. And now we're at number 3. So I'm going to start off with 1.5 grams. And it would have gone down by half. We don't know how many times, but let's figure out how many times it had to half. So it went from 3 to 1.5 in one half-life. And if I just double these, I can kind of work backwards. And then another half-life, it went to, from 6 to 3. And in another half-life, it went from 12 grams to 6. And in another half-life, it went from 24 grams to 12. So I worked backwards, and it says that at the start, it was 24 grams. All right. So it told me that this was my starting number, and this was my ending number. So how many half-lives? So we have 1, 2, 3, 4 half-lives. So it tells us that that took 5,730 years to do this. And so we're going to divide it by 4. Oh, sorry. That is incorrect. I had that mixed up with a different problem. So this is not the right way. It said one half-life is 5,730. And so I'm going to just get rid of this part. So the way that we solve this one is we take 5,730 days and multiply it by 4. And when we do this, we get an answer of 22,920 years. And that's our answer to number 3. And I'm going to go down here to number 4. A 64-gram sample of germanium-66 is left undisturbed for 12.5 hours. At the end of that period, only 2 grams remain. What's the half-life of this material? So let's go ahead and have it from 64 grams. So I have 64, and it's going to half to 32. And it's going to half to 16, and then to 8, and then to 4, and then to 2, and it says 2 grams remain. So how many times did it halve? It halved once, twice, 3, 4, 5 times. So we had 5 half-lives. And so it said that this whole process took 12.5 hours. So what is the half-life? And so this time we're going to divide. I got confused with the last one. So this time we need to find out what the half-life is. So I'm going to go ahead and divide. And I'll just do a simple long division problem here. And our half-life is 2.5 years. Nope, not years. Have my unit wrong. It is hours. Be careful on your units, not to get them mixed up like I did. On the AP test, you want to make sure that on an FRQ you have the right units, so double check them. All right, going on to number 5. With a half-life of 28.8 years, how long will it take 1 gram of strontium-90 to decay to 125 milligrams? All right, so we're going to just start with 1 gram here. And let's go ahead and convert, because here we're in grams and here we're in milligrams. So 1 gram is equal to 1,000 milligrams. So let's half it now. So it's going to half to 500, and then half again to 250, and then half again to 125. And so how many times did it half? Once, twice, so 3 times it halved. And it says that each of them are 28.8 years. And that's times 3. And so when you go ahead and do this multiplication problem, it's 86.4 years. Now be careful. One of the ways the AP test adds a layer of complexity over simple math is by doing something like this, where one number is in grams and the other is in milligrams. It wants you to pick it up. It also wants you to do a conversion. But the AP test will not give you the conversion. It expects you to know your milligrams, your grams, your centi, like centimeters. It also expects you to know kilos and mega, which is 10 to the 6. So make sure you know those conversions. Cobalt-60 has a half-life of 5.3 years. If a pellet that has been in storage for 26.5 years contains 14.5 grams of cobalt-60, how much of this radioisotope was present when the pellet was put into storage? Okay, so it's telling me that it took 26.5 years in storage, and it tells me that the half-life is 5.3 years. So I need to go ahead and do a long division. I need to figure out what the half-life is. And so we'll go ahead and bring the decimal point over, because when you have a decimal point here, it needs to be moved to the end. And then we also need to move this one to the end as well. So our new problem is going to be 53 into 265, because the years will cancel. Now the AP test usually has numbers that divide evenly. So if I look at this, 50 goes into 250 about 5 times, so I'm thinking here that this might be 5. Let me check it over here. 53 times 5. Remember, no calculators, so you got to do this stuff in your head or on scratch paper on the AP test. Do it by hand. And yes, it goes in evenly. So 5 half-lives. So it took 5 half-lives for this process to occur. All right, so we need to find out how much was left. So we started off with 14.5 grams, and we want to do 5 half-lives. So the first one is we need to, all right, so we didn't start off with 14.5. It says that after the storage happened, that we ended with 14.5. So we need to find out what we started off with when it was put in storage. So let's go ahead and double until we have gotten to 5 doublings, which will show the original. So 14.5 doubled is 29 grams. And if we double that again, that goes to 58. And so now we have 1 half-life, 2 half-lives. All right. And then double it again. So 58 times 2 is 116 grams. So that's 3 half-lives. We double 116 to 232. And that's 4. And so we need 5 half-lives. So let's double it one more time to 464 grams. And so it turns out that our original weight of the cobalt-60 was 464 grams. And that's how you do half-life.